JK flip flop using a NAND gate. NAND gate. So how to design? So this one is a NAND gate. Here one NAND gate, one NAND gate is here. This input is input for clock. This one is J. This one is K, J, K, and this output is Q, and this one is Q bar. So it's the next input is this one, this input, and here the next input. This one is this input. So this is a GK flip flop design using a NAND gate. So this one is NAND gate, NAND gate. This one is NAND gate, and this one is NAND gate. So here JK flip flop using a NAND gate. Similarly, if you want to design a JK flip flop using a NOR gate, so how to design a JK flip flop using NOR gate, using NOR gate. So how to design a JK flip flop using a NOR gate? So here one NOR gate, here one NOR gate, one input, another input is here connected to final output, and here we have used AND gate. Here we have used the AND gate. So this one is the input of here. Yes, and one input is a, another input is uh, K. One input is a clock, or somewhere written as the CLK clock, like this. So AND gate, and here the output is connected to like this. So K is this one, third input is this one. So this output is Q, then this output is equal to Q bar. So when you have designed a JK flip flop using a NOR gate like this, so what is the input gates we here use? So this one is a NOR, this one is a NOR, and this one is AND gate. AND gate. So is that clear, or up to this point anyone have any doubts, any query? So this one is a circuit diagram of a flip-flop, JK flip-flop. Is that clear? Up to this point, anyone have any doubts? Any? Yes or no? At least give your
Yes,
response.
sir.
Are you
Clear.
understood?
Yes, sir.
Our question is how to draw the JK latch. So how to draw the JK latch? So in the case of JK latch, just remove this clock pulse. Then the third output is coming here. So only this portion. So only this portion is occur in a JK latch. And this third input is coming here. The third input is coming here. No, this connection is not available in the clock pulse in the JK latch. Is that clear? Yes or no?
Yes, sir.
Now come to the point. How to write down the truth table? This is a very important truth table. So truth table. First, I'm writing here a clock. Then here the input is J, K, and output is considered as the Qn plus one. So this is the truth table. J, K, input and output, like this one. So suppose that the clock pulse is 0. So clock pulse is 0. What happened? When the clock pulse is 0, that means J and K is don't care. It does not affect it. Output is equal to Qn. So what is the meaning of Qn? Qn means memory. So initially those values is available on a memory. That values is a final output. And when the clock pulse is 1, then you can say select JK is 00. When clock pulse is 1, it may be 01. When clock pulse is 1, it may be 10. Or when the clock pulse is 1, both the values is 11. So what is the drawback of JK flip-flop? In the JK flip-flop drawback, if the input, SR flip-flop drawback, so if the input is 1 1, in that condition output is invalid. But in the JK flip-flop, when you have select the 00, it's the values is Qn, its the values is Qn. When you select the values is 01, it is 0, and 10, it 1 is 1, and when 1 1, then in the SR flip flop that values is invalid, but here this values is equal to Q and bar. So this one is called a reset, and this one is called a set. And this is Qn means previous state or a memory. So this is the truth table of JK flip flop. Is that clear, or anyone have any doubts, any query? Yes, up to this point, is that clear now? So now we discuss. So at least give your response, yes or no.
Yes,
Yes,
sir.
sir.
Understood, sir.
Okay.
Understood.
So then after the characteristic equations, truth table, we have draw the characteristic table. So how to write down the characteristic table? So in the characteristic table, I'm writing here like SR flip flop. So this one is J, then K, and then I'm writing a QN and QN plus one. So if this one is the present state, then previous Qn plus one, then previous state is Qn. Qn, or you can say a Qn is the present state, but next state is Qn plus one. Yes, I'm writing here the values. Uh, Yes. So J and K is the input. Qn is the previous state. Then the next state is Qn plus one. So what is the output? So when just to see that what is the value of Jk 00. So when you have select the Jk is 00, understood that the clock is one. So see that what is the value when J clock is one. When J is 00, then you have choose the Qn. That means the previous state, and when j is 0 1, you have choose the 0, and when j is 1 0, you have choose the 1, and when 1 1, just a q and bar. So according to that you have filled the values, final outputs. So what is the values? So I'm saying when j is 0 0, output is equal to qn. So what is the qn here? 0. When j is 0 0, output is qn. What is the value of qn? 1. So I'm writing here the 1 like this. Similarly, yes. When the value is 0 1 0 1, output is 0. 0 1, output is 0. When the value jk is 1 0, output is 1. When the value is 1 0, output is 1. And when the value is of 1 1, so that is qn bar. So 0, so 1 and 1 is 0. So up to this point, anyone have any thoughts, any query? Yes. So this portion is called this one is simply called a hold 0 1, then stay is here. So simply this is called a hold. So this one is the hold, and 0 0, so this is called reset. 1 1, so this portion is called a set. And here in when the previous state is 0 1, the next state is 1 0 in the condition of j and k is 1 1. So this is called toggle. Toggle. So this is the characteristic table of jk flip flop. Is that clear? Yes or no? Up to this point, anyone have any doubts, any query? Yes.
Clear, sir.
After that, the next topic is a characteristic equations. So first draw the characteristic table and then the characteristic equations. Characteristic equation. So how to find the characteristic equation? Here the three variable k map. Three variable. This one is the finding from characteristic table. So three variable k map. Three variable k map. So input is uh, j, k, and qn. This is the input. See that the table. That's why I'm writing the table in this format. J, k, qn is the input. So where is the one qn plus one? Here one at the position of 1 and 4, 1004, 1015, and 6. 1, 4, 5, 6. At that position, value is 1. So here I'm writing the values. This one is the 00 01 11 10 and 01. So where is the one? 1 1 is here, and another one is 4, 5, and 6 in this place. And then now we start pairing. So now we start a pairing. One of the pair is this one. So what is the value of this? J is 01, contradict, remove it, and its the values is K bar, K bar, QN, K bar, QN, K bar, QN. And the next format is next pairing is possible. So these two pairing is possible. Yes. So what is the value of this one? So this one is here the J, and here the values is 00 and 10. So q and bar, q and bar. So simply you can say a qn plus 1, qn plus 1, that is equal to jqn bar plus k bar qn. So this is the characteristic equations of jk flip flop. Characteristic equations of jk flip flop. Is that clear, or anyone have any doubts up to this point? Then
No,
now
sir.
discuss excitation table. So how to write down the excitation table?
Sir, can you please show the previous slide once?
Okay, excitation table. So when you are writing, so how to write down the characteristic equation is written from characteristic table, and how to retain the characteristic table? That table is written from a truth table. Truth table. Is that clear?
Yes, sir.
Okay. Then the how to write down the excitation table. Excitation table. So here the excitation table, one input, one is called Qn. Next one is Qn plus one. So what happened? The value of J and K. This is called excitation. So excitation table. So what is the meaning here? So here put the value of Qn. So how many combinations here? So just now I'm taking a 0 0 when we have choosing the 0 1, and when we have choosing the 1 0, and when we have choosing the 1 1, what happened the value of J and K? So just see in your characteristic table. So when Qn is 0 and Qn plus 1 is 0, what is the value of J and K? So just see that. So when Qn is 0, when Qn is 0 and Qn plus 1 is 0, so these two value, what is the value of J and K? One Jk values is 0 0, and where another one is here the also Qn is 0 or Qn plus 1 is 0. So in this case J and K is 0 1. So you can say now J is 0 but K is 0 and 1. That means don't care. That's why I'm writing here. Uh, that's why I'm writing here when Qn is 0 0, J is 0, but K is don't care. Similarly, when Qn is 0 1, what happens the output? Just to see that the characteristic table. When Qn is 0 1, where is the 0 1? So 1 0 1 is here. So in this case, Jk is 1 1, and when another 0 1 is here. In this case, Jk is 1 0. Yes, na? So meaning is that J is 1 1 but K is 0 1 means contradicts or don't care. So you can write down this values is equal to 1 don't care. Similarly, see that the what happened the Qn is 1 0. Just to see that when the Qn is 1 0, so 1 0 means 1 1, and another 1 0 means 0 1. That means one J is 0 1, that is don't care, K is 1. So you can directly write down the values of 1 0 1 0. This is don't care, but K is 1. Similarly, just to check it, what happened? What is the value of Qn is 1 1? So 1 1, Jk is 0 0, and another 1 1. So J is 1, K is 0. So simply J is here. J values is 0 1, but output is K is 0. So simply you can say in that condition the output is don't care 0. So this is the it's citation table of JK flip flop. JK flip flop. So just see that 0 don't care, 1 don't care, and then 1 don't care 1, and don't care 0. This one is the citation table of JK flip flop. And then what is the um, state diagrams? Just now I'm discussing with you state diagrams. State diagram. So state diagrams having a two state. One state is called 0 0, and another state is 1, two state. And just I want to change the just to see the excitation table. So when you have going from a 0 to 1, when you have going from 0 to 1, what happens? The values J is 1, J is 1, but K k is equal to don't care. And when you have going from 1 to 0, 1 to 0, that means input state is 1 and output state is 0. In that condition j is equal to don't care, but k is equal to 1. Similarly, when you have going from start from 0 and come back to 0, in that condition j is 0, but k is equal to don't care. Or when you have starting a 1 and come back to 1, in that condition j is don't care, j is equal to don't care, but k equal to 0. So this one is the writing from values is through a citation table. Yes. So up to this point, anyone have any doubts, any query? So